Continuing with our free reduced lunch example, we have a school, we call it K, that has values 2260. Explain what these values mean in the context of the situation. All right, so this you'll be asked to do very frequently. So it's a question of checking that you understand that this is an ordered pair, that the value that comes first is an X and the value that comes second is a Y. And all you're doing is tying them back to what the X and Y variables were, either through the graph or through the chart, or both. Right. So the percent of students on free reduced lunch, which is your X, is 22. So you would say school K has 22% of students on free reduced lunch. There's no script for this. All you're doing is tying the variables back to what they were. You're proving that you understand that when you're given an ordered pair like this, that's X and you know what X was for this problem, and that's Y and you know what Y was for this problem, right? So it has 22% of students on free reduced lunch and 60% of its students for this school passed the state math exam. So you understand that's X, right? And what X is, and this is Y, and what Y is. So you're proving that you understand the context. So this was X equals 22. What did that mean? And this is Y equals 60. And what did that mean? That's it. It's not a script. It's just going back to basics, going back to the variables. All right, now the nearby Amber High School has 40% of their students on free reduced lunch. What does the least squares regression model predict past the math exam? Okay, so first of all, this little fancy phrase right here, that's the line of best fit. That's the least squares regression model. It's the one that we're working with. Oops, line of best fit. Sorry. So there's so many names for it. The trend line, all sorts of things. But we can call it all sorts of different things in the problems. It always means that line. Okay, so what are they telling us? They're telling us that Amber High School had 40% of students on free reduced lunch. So that's another way of saying, hey, X was 40, right? X was 40 for this school. And what's Y? Now, before we go any further, we need to kind of predict past the math test. That's Y equals question mark. We have to figure out, do we change the 40% to a decimal or do we leave it as 40? So let's go back and look at the graph and the table. So you'll notice, and this is the one chapter where this is the case, the percents are actually left as percents. We don't rewrite them as decimals. This is the only chapter really that is true. So we're going to leave them as whole numbers because if you look at the graph or the table, they're left as whole numbers, not decimals. So I'm going to make a little warning right here. Right? Use X equals 40 because the graph and the table use whole numbers, not decimals. So you don't want to get yourself into the trap of thinking, hey, it's a percent, I'm going to have to change it to a decimal. That is not the case. In this case, you would leave it as whole numbers. All right, so let's leave it as whole numbers. So the equation that we found for part A was y hat equals 69.108 minus 0.283x. So what we're going to do is we're going to take x equals 40 and we're going to substitute it in. So we're going to say 69.108 minus 0.283, and where there was an x, and that's multiplication right there when you have a number times a variable like that. So we're going to multiply it times 40, not 0.40, 40. We use the whole number because that's what the table and the chart did, or the graph did. Okay, so we're just going to go grab Desmos and figure that out. That's what Desmos is for. So 69.108 minus 0.283 times 40. Now you can use the time symbol or you can use the parentheses. Right? Parentheses in this case would actually just be multiplication. It's not really a grouping symbol because there's nothing in there with the 40. So either way we go, we get 57.788. Now, what would that be? That would be percent that passed the math test. Percent because that's your unit, right? It asks it right here, percent. And again, it will not always be percents. It just was in this case. Sometimes it'll be feet. Sometimes it'll be dollars. Sometimes it'll be dollars per gallon. You know, it can be all sorts of things. There we go. Now, was Amber High School outside the scope of our model? Okay, well, for that, we would want to take the 40, x equals 40, and kind of go look at our data points. So we could look in here in the graph, or we could look over here in the table. And you can see that 40 is amidst all the other data points. Now, there's no state or school that is 40, but that's okay, right? It's amongst the other data points. So it is not outside the scope of the model, right? It is well within the scope of the model. So we will say no to this. Actually, let me write x equals 40. Percent was among the other x values of the data set. Right? It was in and among them. It was not separate from them. It was not off on its own. Okay, so let's determine the residual for Amber High School. If they actually had 65% of their students pass the math test, interpret that residual in the context of the situation. Okay, so residuals are that formula that we've learned. It's the actual y minus the predicted y hat. Right? That's the formula. So what was the actual y? Well, what they actually had in real life is right here. So there's their real life value, and it's 65. So it's 65%, if you will. Take away, and then our prediction. Our prediction is right here. That's from the equation of the line. So that was 57.788%. Percents are the units in this case. It could be feet and feet, inches and inches, points and points. It could be all sorts of things. But that's just what it is in this case. All right, so let's go grab Desmos and say, hey, what's 65 take away 57.788? And we get 7.212. Okay, so this is 7.212. And again, in this case, it's percent. And it's percent passing the math test. Just to remind you, it's y values. The y values were the passing of the math test. We labeled them right here so that we wouldn't forget. Right? It was the passing of the math test. Okay, so we have to interpret this residual in the context of the situation. So how is Amber High School doing? So let's think about the graph actually for a second. So 40 is right here. So Amber High School, we predicted would be right here. So that's our prediction, was 57.788, right? Yeah, 788%. But where Amber actually was 65, which is up here. So when we found the residual, we're finding how far apart these two dots are. The prediction's always on the line, and then the actual value is off of the line. So how far apart are these? They're 7.212 apart. Now, how is Amber High School doing? Well, it's doing better than expected because they're having a higher percent passing the math test than we expected. So I just wrote that, right? They're doing well. In this case, it's a positive residual, right? Positive residual because it's above. And in this case, that was a good thing because that means that they have more students passing the state math exam than would be expected otherwise. Now, suppose a private high school wanted to use this regression model and all of these data to make predictions as well. Why would that not be appropriate? Well, you have to remember that our particular data set was built entirely from public schools right here. So it's only fair to compare it to other public schools. It would not be appropriate to compare private schools to this because private schools have different rules and regulations involving them. There, and I just wrote that up. So again, you have to compare apples to apples, right? You can't compare apples to oranges. You can't take a place that has entirely different rules and regulations or lack thereof and compare them to a different group. Oops, if I could spell apples.